In this video, we're going to go over number 6 and 7 from the practice test. For number 6, I'm not really going to go over the whole thing. If you have questions about doing stuff on your calculator, send me a message separately. As I said in class, there's a lot of great YouTube videos already out there about just doing the regression part. For part B, what we said in class is your answer needs to reflect both how well your equation fits the scatter plot. So you just have to look at it. Look at the scatter plot on your screen. Look at the graph of your equation on your screen and say, yeah, it does a really nice job of going through those points. But make sure that that's true, right? Don't just assume that to be true, because what you're doing is you're helping yourself decide what type of function you should use. Like maybe you try one at first and you're like, oh wait, actually that doesn't fit very well. And then you try a different one and you say, oh, that fits much better. Also, you need to think about the context. Does this make sense in context? In this case, I would say exponential decay is probably a great fit in context, because you can see that the production is decreasing, but we know eventually that has to have a horizontal asymptote at 0 or some similar number. If you chose maybe quadratic, which is reasonable, you would then need to say, but the second half of my parabola is eventually going to show that the production is going to go back up, which is possible. You know, maybe a new part of the well suddenly, kicks in, or you drill a little deeper. But we would just need to address that and say, hey, this parabola is going to go back up eventually. The end behavior is going to be towards positive infinity. And that doesn't actually fit what the data is showing me. That doesn't fit in context necessarily. So we need to explain why we chose our model, both in terms of how well we fit the scatter plot and whether or not that type of function makes sense in the long run for the context here. And it's okay to say, hey, in the long run, the parabola doesn't make sense, but for these points, yeah, it makes sense. Residual, remember, key to the residual, since I'm not going through the equation, I don't actually have it in front of me. Just remember that the residual equals the observed minus the predicted. In other words, what the table shows me minus what my formula tells me should happen. It's what my table shows me did happen minus what my formula tells me should happen. And we're just looking at that. It's a measure of how close we are, how accurate our model is for a particular point. All right, so that's all I'm going to say for number 6. Number 7, looking at, okay, where's our first mistake, if there is one? So we're given this exponential equation, and we had a similar one back in number 3, where what we did in number 3 was we just took the natural log of both sides and then used that property of logarithms to move this exponent out front. But what we're doing here is we're saying, all right, let's rewrite this in terms of log base 4. Now we also could have done it in terms of log base 3, but here they did it as log base 4, and that's totally fine. That's all that's happened here. We said log base 4 of this other side equals this exponent. If we look at a simpler case, 25 equals 5 to the second. Well, I could rewrite that as log base 5 of 25 equals 2. That's all we've done in step 1. Now in step 2, now I use that property of exponents to say, well, our property of logarithms to say that this exponent inside the logarithm can be moved out and become a coefficient in front. And then we just left the 2x. That's all good. Now this log base 4 of 3, that's a number, and there's 2 things I could do with it. I can either distribute it or I can divide it over here. It looks like they tried to distribute it, but they didn't. They distributed it to the 1, but not to the x. So that's our mistake. After that, they did it right based on what they had. They just subtracted the x over, and that's fine. But the question says the first step in which a mistake was made, which is step 3. All right, that is all for the Schoology portion here.